Chapter 9. Some applications of trigonometry. The presentation is structured as follows. 9.1 Heights and Distances. 9.2 Summary. Heights and distances. Trigonometry is very useful for measuring heights and distances that are difficult to measure directly. This section will explore these applications. Key terms. Line of sight. This is the imaginary line drawn from the eye of an observer to the object they are viewing. Angle of elevation. This is the angle formed between the line of sight and the horizontal when the object being viewed is above the horizontal level, for example, looking up at the top of a tower. Angle of depression. This is the angle formed between the line of sight and the horizontal when the object being viewed is below the horizontal level, for example, looking down from a balcony at an object on the ground. Example 1. Height of a tower. Problem. A tower stands vertically on the ground. From a point on the ground 15 meters away from the foot of the tower, the angle of elevation to the top of the tower is 60 degrees. Find the height of the tower. Solution. We can represent this situation with a right-angled triangle ABC, where AB is the height of the tower, BC is the distance from the tower, 15 meters, and the angle ACB is the angle of elevation, 60 degrees. To find the height AB, we use the trigonometric ratio that involves the opposite side AB and the adjacent side BC, which is the tangent. The equation is tangent of 60 degrees equals AB divided by BC. We know that the tangent of 60 degrees is the square root of 3. So the square root of 3 equals AB divided by 15. Solving for AB, we get AB equals 15 times the square root of 3 meters. This is the height of the tower. Example 2. Electrician's ladder problem. An electrician needs to repair a fault on a 5-meter pole. She needs to reach a point 1.3 meters below the top. What should be the length of the ladder if it is inclined at a 60-degree angle to the horizontal? Also, how far from the pole should the ladder be placed? Use the square root of 3 equals 1.73. Solution. The height the electrician needs to reach is 5 meters minus 1.3 meters, which is 3.7 meters. This forms the opposite side of our right triangle. To find the length of the ladder, the hypotenuse, we use the sine ratio. Sine of 60 degrees equals opposite over hypotenuse equals 3.7 over BC. Solving for BC, the length of the ladder is open parenthesis 3.7 times 2 close parenthesis divided by the square root of 3, which is approximately 4.28 meters. To find the distance from the pole, the adjacent side, we use the cotangent ratio. Cotangent of 60 degrees equals adjacent over opposite equals DC over 3.7. Solving for DC, the distance is 3.7 divided by the square root of 3, which is approximately 2.14 meters. Example 3. Height of a chimney. Problem. An observer who is 1.5 meters tall is standing 28.5 meters away from a chimney. The angle of elevation from her eyes to the top of the chimney is 45 degrees. What is the height of the chimney? Solution. This scenario forms a right-angled triangle, ADE, where AE is the height of the chimney above the observer's eye level, and DE is the distance to the chimney, 28.5 meters. We use the tangent ratio. Tangent of 45 degrees equals AE divided by DE. Since the tangent of 45 degrees is 1, we get 1 equals AE divided by 28.5, which means AE equals 28.5 meters. The total height of the chimney is the sum of AE and the observer's height, 1.5 meters. So the height of the chimney is 28.5 plus 1.5 equals 30 meters. Example 4. Building and flagstaff. Problem. From a point P on the ground, the angle of elevation to the top of a 10-meter tall building is 30 degrees. A flag is hoisted on top of the building, and the angle of elevation to the top of the flagstaff is 45 degrees. Find the length of the flagstaff and the distance of the building from point P. Use square root 3 equals 1.732. Solution. First, consider the right triangle PAB to the top of the building. We use the tangent ratio. Tangent of 30 degrees equals 10 divided by AP. This gives the distance of the building from point P as AP equals 10 square root of 3 meters, which is approximately 17.32 meters. Next, consider the right triangle PAD to the top of the flagstaff. Let the length of the flagstaff be x. The total height AD is 10 plus x. We use the tangent ratio again. Tangent of 45 degrees equals the quantity 10 plus x, all divided by 10 times the square root of 3. Since tan 45 degrees equals 1, we solve the equation 1 equals open parenthesis 10 plus x close parenthesis slash 10 square root 3, 4x. This gives the length of the flagstaff as x equals 10 times the square root of 3 minus 1 meters, which is approximately 7.32 meters. Example 5. Shadow of a tower. Problem. The shadow of a tower is found to be 40 meters longer when the sun's altitude is 30 degrees than when it is 60 degrees. Find the height of the tower. Solution. Let h be the height of the tower, AB, and x be the length of the shadow when the angle is 60 degrees, BC. The length of the shadow when the angle is 30 degrees is x plus 40, dB. From the smaller triangle ABC we get tangent of 60 degrees equals h over x, which gives h equals x times the square root of 3. From the larger triangle ABD, we get tangent of 30 degrees equals h over x plus 40. Substitute the value of h from the first equation into the second and solve for x. This gives 3x equals x plus 40, so x equals 20 meters. Now find the height h. h equals 20 square root of 3. Therefore, the height of the tower is 20 times the square root of 3 meters. Example 6. 2 buildings. Problem. From the top of a multi-storied building, the angles of depression to the top and bottom of an 8-meter tall building are 30 degrees and 45 degrees, respectively. Find the height of the multi-storied building and the distance between the two buildings. Solution. Let PC be the multi-storied building and AB be the 8-meter tall building. The distance between them is AC. The angles of depression create alternate interior angles, so angle PBD equals 30 degrees and angle PAC equals 45 degrees. In the right triangle PAC, tan 45 degrees equals PC over AC. Since tan 45 degrees equals 1, PC equals AC. In the right triangle PBD, tan 30 degrees equals PD over BD. This gives BD equals PD times the square root of 3. We know that AC equals BD and PC equals PD plus DC. Since DC equals 8 meters, we can form the equation PD plus 8 equals PD square root 3. Solving for PD gives PD equals 4 times the square root of 3 plus 1 meter. The height of the multi-storied building is PD plus 8, which is 4 times 3 plus the square root of 3 meters. The distance between the buildings is the same. Example 7. Width of a river. Problem. From a point on a bridge 3 meters above a river, the angles of depression to the opposite banks are 30 degrees and 45 degrees. Find the width of the river. Solution. Let P be the point on the bridge, and A and B be points on the opposite banks. The height of the bridge DP is 3 meters. The width of the river is AB, which is AD plus DB. In the right triangle APD, the angle at A is 30 degrees. Using the tangent ratio, tan 30 degrees equals 3 over AD, which gives AD equals 3 square root of 3 meters. In the right triangle PBD, the angle at B is 45 degrees. So BD equals PD, which means BD equals 3 meters. The total width of the river, AB, is AD plus BD equals 3 square root of 3 plus 3. Therefore, the width of the river is 3 times 1 plus square root of 3 meters. Summary. Here are the key points studied in this chapter. The line of sight is the line from an observer's eye to the object being viewed. The angle of elevation is the angle formed by the line of sight and the horizontal when looking up at an object. The angle of depression is the angle formed by the line of sight and the horizontal when looking down at an object. The height or distance of an object can be determined using trigonometric ratios. Thank you for learning with us.